Now let's talk about active, static, deforming, and animated states when it comes to RPD simulations. Starting with active, whenever we say something is active, what that means is that the forces and the relationships that are specified in DOPS are allowed to affect the particular active object. Also, objects that are active are allowed to affect other objects. So I've tried to explain this with visuals right here. We have this ball, it's bouncing off the ground, and this represents forces that are able to affect the ball, which could be, let's say, an active object. Down here, if a ball goes through, let's say, a brick wall, that could be an example of, let's say, the active object being the brick wall, and that is allowed to be affected by another object in the scene, which could be the ball that's breaking through. Compare that to a static object, and we have the opposite thing happening. So a static object says that forces and relationships are not allowed to affect the static object. Objects that are static are not affected by other objects in the scene. However, other objects are also allowed to collide with a static object. So here, back to this bouncing ball example, gravity will not affect the ball, the static object. And down here with the brick wall, let's say that the static object is the brick wall. No matter what we do to that brick wall, nothing will affect that object. No other object will break that wall apart. But other objects, other active objects in the scene, are allowed to bounce off of that. Next up, we have deforming. The deforming attribute tells the solver that it needs to update the object at every step. So think about loading in the deforming object at every single step of the simulation. The collision mesh, that's the blue geometry that represents what the solver sees, gets rebuilt at every step of the simulation. And so one thing you have to be careful about is that because it's rebuilding this collision mesh every single time, it will take more time to do that on every single step. Also, it can only take transformations that happen within SOPs. So if you have any kind of animation at the top geo level, that won't work. But if you have the points moving around because of things happening in SOPs, it will pick that up. And that is deforming. Animated refers to something different, and this is where things get a little bit tricky. So an animated object is basically the same thing as deforming, except this works faster. And what's happening here is that the animated object only updates the position and does not rebuild the collision mesh at each step. That makes it a lot faster because it's not rebuilding the collision mesh. And because of that, it also has some limitations just by how it works. So for one, it can only work with static objects. So objects that have, active as 1 or anything that's set to active will cause animated to not work. And that's just due to how animated runs under the hood. And also objects which have animated equal to 1, they're not going to pick up any transformations which are made at the top object level. So just like deforming, it only looks at the changes that have been made within here. Also know that animated only takes a transform. So let's say that you had like a mountain SOP changing over time. Because animated is not updating that collision mesh at every single step, that's not going to carry over with animated. Instead, that's when you would want to use deforming. Or let's say that a character had some kind of blend shape, right? Those points are changing over time within SOPs. Well, that change because of the blend shape means that the collision mesh needs to be updated at every single step. You're not going to be able to use animated in that situation. And so, again, why use animated? Well, because it's faster. And so the rule of thumb here is that use the animated when you have something that is deforming and it's a static object and you only want to change the transformation. Basically, in any situation that you don't need to rebuild the collision mesh, that's when you want to rely on the animated. Also, if you have any changes that happen at the top object level, we do have this thing called use object transform, and I'll show you that here in a minute, and that's what you want to use in order to read any animation that's at the top level. In the next video, let's see how this plays out within Houdini.